Right. Thank you again. Another wonderful talk. I have lots of questions, especially coming from the Center for Product Design and Manufacturing, where we do teach what all you just concluded. And it's kind of surprising that we don't have enough interaction within the campus itself. All right. So with that, I'll go to our next speaker. Our next speaker is Dr. Anand MS from the Center for Sustainable Technologies. Dr. Anand's team and collaborators have developed an S3 medical oxygen concentrator. Dr. Anand is a senior research scientist at CST. He completed his MTech in Energy Systems Engineering from BVB College of Engineering and Technology, and his PhD from ISC Bangalore. Yeah, so you have.
Yeah, too many windows going up. Now which one?
Yeah, both.
Both one?
Yeah.
That's one, right?
Handling Apple is something which I'm still struggling.
Took me a while.
Good at it.
So just share the screen.
Yeah. Hello. Am I good to go, please? Yeah. Namaste to everybody. Greetings on this auspicious occasion of Mahashivratri. After two interesting talks, wherein we heard some nice innovations and some challenges, I'm going to present one more story, which again will, I feel, related to some of the stories or some of the flow that we heard just now from Professor Roy as well as Professor Rasti. I'm going to talk about S3 medical oxygen generator, and I'm describing it as a story of a technology offshoot. Now, why exactly I'm describing it as a story of technology offshoot? It was interesting that in the course of our own journey of doing some science, we have understood some things. And then we realize that, okay, this is something which we already understand, which we have some expertise on. And this is something which we can extend to address some problem associated with the need for medical oxygen. That's why I describe it as offshoot of our own understanding. And symbolically, I'm representing it as a main river, which is just branching it out. Before I actually go into discussing about the medical generator itself, I would like to give a small glimpse of what exactly we are doing. That way, I will be able to correlate it with
what exactly we did with respect to the innovation for COVID. Now, this is a prequel. I thought I will present this as a running story rather than a technical discussion. So, prequel to this entire thing. Necessity is the mother of all invention, as said by Plato. Came through during one of our own encounters with respect to a particular technology. Now, what exactly we do at my lab, that is combustion, gasification, and propulsion laboratory today under ICER, is that we deal with a lot of biomass. This biomass is converted in a gasification system. It's a system which converts solid biomass into a mixture of these kind of gases. They contain like hydrogen, carbon monoxide, methane, carbon dioxide, nitrogen, so on and so forth. So our own forte is to convert solid biomass of any type into a mixture of gases. And what do we do with these gases? We use these gases for generating electricity through the internal combustion engine route. The other way of looking at it is we can directly burn these gases to generate heat. So this is what is our, I can say, bread and butter. This has been our bread and butter, trying to understand the basics involved in conversion of biomass into different types of gases, how best we can convert, so on and so forth, and then how efficiently we can use these gases for downstream processes. Now, what exactly happened was this work started somewhere about a couple of decades back. Things were very rosy. We were generating electricity, we were generating power. Then came the technology of solar. Once the solar technology came in, what exactly happened was the cost of generating electricity by solar was way too lower than the cost associated with our own technology. Now that kind of made us or made our technology take a significant backseat. The technology was there, but commercials brought in a factor which actually pushed the technology back. Now, we had to rethink as to what exactly are we going to do with this particular technology. When we really deliberated about what exactly are we going to do with a mature technology, then it struck to us that what we are generating from biomass is basically a mixture of these gases: hydrogen, carbon monoxide, methane, carbon dioxide, nitrogen, so on and so forth. And today, without bothering about those gases, we are directly further converting it into either electricity or heat. But if you look at the broader market, there is a significant demand for these gases if they are separated out. If the gases are separated out, then there is a beautiful market for that, and that market can fetch significant amount of revenues. So that is when we decided that, okay, we have a very mature technology, and now we have this gas. If we can do something to separate these gases out into individual components, then that's where we are going to make a lot of, if I can call it as money, if not anything else. That is where our target is. So that is something which gave us a renewed focus on working towards this aspect. That is, now we are interested in seeing how are we going to separate these gases rather than thinking of how to economically convert this into electricity. That we just left it aside. Now, when we did some research regarding what kind of technology we can use to separate these gases, a mixture of gases, into individual components, one of the technologies that was well established, mature at commercial scale and economical was this separation system, that is vacuum pressure swing separation system. So we came to know that this is a technology which can actually do the job that we want. We identified the technology, and the biggest shocker to us came when we realized that in India we don't have this technology. It's a rather simple technology, but in India we don't have it. Technology per se is not very complex, but we don't have it. What we did was, okay, fine, we don't have the technology. Now we have to seek the technology from abroad. So we contacted companies in Germany, we contacted companies in Canada, we contacted companies in the US, so on and so forth. The first biggest challenge came in was they say the scale at which you are looking at is rather small. And second thing is they initially started to discuss some technological aspects regarding the system, but ultimately it came to a point wherein, in spite of being ready to pay a premium for the product, the companies point blank refused to sell any of these technologies. It was a shocker for us. They refused to sell any of these separation technologies to us because probably they kind of got a feeling that okay, this is something which we can reverse engineer. So that was a biggest shocker for us. No company was ready to. One company actually gave us quotation, and then when it was at the stage of going for tendering route, because this technology runs into crores, we had to go for tendering route, and then when we finally saw them the final set of documents for hosting the tender, they just backed out, saying that no sir, we are not going to sell it. Interestingly, they said they did not say we are not going to sell it. They told us our lead time is going to be 36 months. So by the time it is going to be 36 months, the project itself is going to be over. So there was no way we could actually accommodate any of these requests. Now that actually pushed us back to the drawing board. We did not have any choice. We had a technology which was generating a mixture of gases, but we did not have a technology which could separate out these gases. So that's where we decided to go back to the drawing board and started from the fundamentals. We knew that this separation technology is not rocket science. It can be done. Unfortunately, it has not been done. So we went back to the drawing board. We put up one PhD student on this particular thing to work, and over a period of some 3-4 months, we had our first Eureka movement. We developed the technology for separation. This involved a lot of fundamental work, wherein we first constructed some control columns to see how we can separate the gases, so on and so forth. So we had this success. This was the first low-cost separation system that we have developed, and we have deployed it in our lab. So this is the technology which actually separates out hydrogen from all other gases. So today on the campus, in the country, and probably across the globe, ours is a unique laboratory which separates out ultra high pure hydrogen from a mixture of gases which are generated from gasification of biomass. So this is what we define as green hydrogen, and we have received a patent for this from the government of India. We are now trying for patent in US as well as Europe. But this was a technology which we kind of developed, and then the knowledge base was developed. With this as a background, now I will come to the medical oxygen generation system story. Again, no need to really deliberate on this. Somewhere around this time in the year 2020, this scenario struck us. We had this challenge of medical oxygen shortage. When we deliberated that, okay, there is a lot of medical oxygen shortage that people are facing, especially in the second wave. We had a lot of deaths that were occurring in different hospitals, so on and so forth, because of lack of oxygen. That is when we kind of sat together and discussed that, okay, what exactly is the need here? The need here is medical oxygen. How is the medical oxygen being generated? The simplest way in which medical oxygen today is being generated, whether from local machines or the machines imported from abroad, is separating nitrogen and oxygen. Basically, we have air which contains 21% oxygen, 78% nitrogen, about 1% argon, and some trace gases. So all that we need to do is remove nitrogen from the mixture or remove nitrogen from air, and voila, what you have is medical grade oxygen. So this is something which is already in our knowledge. We already know how to separate more difficult gases like hydrogen, carbon monoxide, so on and so forth. So what we decided was, we will now look at adopting the knowledge base that we already have, adopting the system that we already have for developing the medical oxygen generation system. So we already, as I said, we already have the knowledge base, and then we just need to extend it. Again, all this activity started when the institute was under lockdown, the country was under lockdown. We were all forced to work from home. my student was sitting in Punjab, I was sitting in Matikere, my professor, Professor Hazap was sitting in Rajanagar, so on and so forth. So all of us were distributed across different places, connected remotely, and then we basically established the basic design of what exactly we are going to do. Understand the guidelines. This is very important because generating hydrogen is one thing, because that will ultimately go into some kind of a system where you either burn it or do whatever. But here, medical oxygen is a different ballgame altogether. As Professor Avasti also brought out, this is something which a human being will ingest. So we had to understand the philosophy as described, or guidelines as described by Ministry of Health and Family Welfare. They have stringent guidelines describing how a medical oxygen generation system should actually be. What are the materials to be used? What are the safety guidelines that needs to be taken? So all these guidelines were understood. We discussed with number of people. We discussed with some people in ministry also to understand what exactly they mean, because sometimes we feel that the wordings are very cryptic in nature. We really don't understand as to what do they mean by that. And many times standards are set very high, but there can be a flexibility when it comes to practical implementation. So these are the things which we actually try to understand. Then we started communicating with the suppliers, because we understood the philosophy of assembling the system, and we were very clear that we are not going to do any re-engineering. We are going to make use of the system or the components as available in the market, assemble them, and then try to give out a system. Having done all this, we still had to do some control experiments. So for that, again, Institute supported us by arranging some curfew passes or so on and so forth for us. For about 3 days, we put up some kind of a tent within the laboratory, wherein we went with some basic food, so on and so forth. 3 days, we stayed in the lab, did some control experiments to get an idea about what should be the residence time of air in the column, so on and so forth. Because we had done that for hydrogen, we had not actually done it for oxygen. We had not done it for the kind of bed material that we are using. So we had to still do some control experiments, even though we had some idea about what we are looking for. Based on the basic experiments, so on and so forth, the first prototype of the medical oxygen generation system was ready. Now, the best part of this medical oxygen system came in, I call it as the broad guideline of our country, that is Vasudhaiva Kutumbakam. We wanted n number of components like walls, stainless steel towers, bed material, medical oxygen detectors, sensors, knife edge walls, so on and so forth. There were n number of components. We struggled hard to actually connect with all the suppliers. Now, the best and beautiful post for me, it is very emotional experience. I told them, see, we need these components, please. Currently, the situation is that we are all under lockdown. So for us to go ahead and then get you a PO, so on and so forth, it may take a little time. Can you please take our word for the fact that we will pay you money, and can you start supplying the items? Not one single vendor refused. Not one single vendor refused. They said, sir, you please send us the specification. We will ensure that the items land up in your lab. So most of the items we got from different parts of the country. We got the zeolite, the basic material which helps in separating out nitrogen from oxygen, from New Delhi, which was in turn imported from France. So somebody took all the trouble of importing it from France by exercising some leverage there, got us the material. Somebody from Coimbatore sent us the control flow walls. Somebody sitting in Electronic City designed the control box. He individually took care of arranging a curfew pass for himself, delivering the item all the way till this. So basically, a lot of people came together, helped us in assembling or arranging all the materials, and finally, this is what was the first medical oxygen generator that we developed and tested in our lab. Now, this particular system, when we developed and tested it, one of the secretaries from government of Karnataka came in, and then they just saw the testing. At that time, that lady got a call saying that there is some emergency happening in Rajanagar, sorry, in Rajageshwari Nagar ward. She said, sir, can you ship it? Can I arrange for a truck, and then can I take it? He told clearly that, madam, this is still not certified. It is working, it's all fine, but it is still not certified. So please explore whether this is something which is legally permitted. After that, I think they somehow managed the situation over there. This facility is still there in our lab. We did a lot of testing on the facility also. So you can see we are getting 93+% oxygen. This is on a calibration system. This is on the practical system that we implemented. Typically, most of the sensors that we have, they are all available in low concentration range. Now, what we wanted was a medical oxygen generator in the high concentration range. So we had to struggle a little bit to actually discuss with the supplier to recalibrate their sensors. So it was an interesting journey there. We did some more critical testing to establish the cyclic stability of the system. And then once this entire system was ready, we coordinated with our IP cell to license out this particular medical oxygen generator. The idea here was, we thought, okay, we have now developed the system. We will adopt two philosophies. One is a 50 liters per minute medical oxygen generator plant should be released under open license. So what we have done is, we have released, we have released a 50 news connection, I suppose. Yeah. So we have released a 50 liters per minute medical oxygen generator design as an open source design. So we disseminated the information using webinars and we disseminated some information using webinars. A full design document with specifications, list of suppliers, so on and so forth has been released. So this is still residing on our institute website. The complete documentation is available, and for higher capacity systems like 200, 600, 1000 liters per minute capacities, so on and so forth, we decided to license out. So somewhere about 18 companies have taken the license for this, and by paying some royalty or so on and so forth to the institute. These are some installations that we have kind of realized across the country. One particular installation is something which is very interesting. This 75 liters per minute medical oxygen generator plant, which has been installed in Lucknow in St. Mary's Hospital. One fine day, I got a call from an elderly gentleman saying that, Baba, I want to do something for the society. I am a retired professor from Indian Institute of Management. I have some funds in my bank account. Can you please facilitate me establishing a medical oxygen generator based on your design in my city? This was all his request. So he said, sir, welcome, we can do that. He immediately said, I can apportion some 25 lakhs for this. Now, money was there, design was there, suppliers were also there. The question was whether we should pay the suppliers and then send the equipment to Lucknow and then hope that the entire thing will be assembled and aggregated, or to try and aggregate it here and then ship the system to Lucknow after testing. That was the dilemma that we were facing. Ultimately, we decided that no, we should assemble it here and then send it to Lucknow. So this entire plant was built. We tested it exhaustively in our institute. That gentleman was very clear that it had to be there in Lucknow by 15th of August 2021. Unfortunately, because of some supply chain restrictions, we could not really make it by 15th August. That is when we requested our institute director to kindly grace the occasion to inaugurate this online. We all went on the video conference. The director came to our lab. We made we had an online inauguration of this facility, and then from then on, we, without disassembling this, we containerized this and then shipped it to Lucknow. Now, there is again one more beautiful story associated with this. Once this system reached Indore, somewhere at about 12:30 at night, I got a call. I mean, midnight, 12:30 is 1 o'clock. If you receive a call, it's a little scary. So I suddenly was scared as to what exactly happened. Somebody said, sir, I'm calling from police department. I said, I was further scared as to what exactly has happened. Then he said, no, sir, we have a truck which is carrying some equipment. I don't know, which is carrying some equipment, and they have papers for individual components, but they don't have a set of papers for a consolidated unit. So the drivers are unable to explain to me what exactly is this, and they gave me your number. And I told him, sir, this is what exactly it is. So this has to be shipped to Lucknow to be deployed in a hospital in Lucknow. So I humbly requested him, sir, can you please help? Because neither the drivers are aware of what exactly is the entire system, nor the end party is also aware. He's an 80-year-old professor who had just decided to fund this. So then I made a specific request. The police department then put me up with the higher authorities, and then they said, sir, आप चिंता मत करो, ये पहुंच जाएगा. That's all he told me. Next day I called up the driver and asked him, क्या हो रहा है, क्या आपका item निकल गया? And he said, sir, when you talk to the police officers, they made an arrangement for escort vehicle to take our system all the way to Lucknow. So that is something which was very emotional again to me. In this effort, Dr. Dasap was involved, myself and the student Arshdeep Singh. And yes, that's the story. Just I can give a glimpse of the document that we have released. How do I do it? Please, I'm sorry. There is a PDF which I just want to show a small glimpse of, please.
Online also, right?
Yes. That PDF is what I. Thank you, person.
Here.
So this is the document that we released. The open source design, we again gave all the disclaimers, what to do, what not to do, so on and so forth. Gave a small preamble about what medical oxygen is, what are the contaminant limitations, so on and so forth. Everything was indicated. And this is the list of items as per the specifications. Here, how should it be? What should be the material it should be made up of, so on and so forth. And
Oh. Let me try once again, and if not. This one, right?
Yeah.
It's coming.
So compressor package, what all components go into this? And then we also released the CAD drawing because that was very important. Each component to its individual dimensions, nuts, bolts, control logic, how to design the control logic, what timing should go into this. Now these are some things which no company will actually release. The essence of that entire separation system lies in the timing. This is something which a company doesn't really release. So we even have released this, and we have identified the suppliers who all supplied what components, so on and so forth. It's a rather exhaustive list, and performance data, how exactly our system has performed, so that if somebody goes ahead and then manufactures it, then what kind of performance they can expect. If they have a wherewithal to actually measure the components, then what should be the yardstick? So we have released some benchmark data. Typically, what happened was when we organized 2 or 3 webinars, a lot of questions were asked to us by different people. So we also consolidated those questions so that people can see. Ultimately, there was some idea that we should not get back too many questions, because this was an initiative from our end, but not the bread and butter of our research. So we also put up some of those questions, and in annexure, we have given the process flow diagram, how exactly it works, what exactly happens. This we gave out because there were many students from engineering colleges who expressed interest in developing this. So that for them to take it forward, okay, these are actual engineering drawings. These are actual engineering drawings. Using this, anybody with, if these drawings are given to a manufacturing company, they will be able to design and develop the entire thing. Yeah, with this, I would like to thank you all.
Thank you again, Dr. Anand. Another wonderful talk. It's been a sort of a very interesting session.